Okay, now we're going to start digging into some really exciting stuff. Trig equations, in their introductory form, are generally just an exercise in factoring and substitution and the unit circle. What we're doing now is getting into some trig equations that are a little more intermediate level. Okay, these involve the complicating factor of using trig identities, which we spent quite a bit of time on in a previous unit and we'll get to review now, which should just be a pleasant exercise since you've memorized them all, right? So take a step back for a moment. Our goal in every trig equation is to isolate the trig functions. Okay, we want it in the form of some parentheses, like sine of x plus 1 and 2 cosine of x minus 1, right? Then from that, we can pull our solutions, okay? And we've done those before, so I'm not going to go over those too much right here. Now, the method that we do to get to this point, the method that we, whoa, that's an eraser. The method that we use to get to this point right here is factoring, or it has been generally. And that's either, if you have all the same trig functions like cosines everywhere, check the GCFs and then check trinomial factoring. If you have different trig functions, that's a little more annoying. Generally, we just do GCFs there. And factoring is a little hard when you have different trig functions. So now I'm adding on a new tool, that of trig identities. And there's several trig identities that we're going to rely pretty heavily on. Quotient trig identities, such as tangent equals sine over cosine. Pythagorean trig identities, and here you have three. You have the Santa Claus identity, the tan secretary, and cottage cheese. Okay, remember our three favorites from the Pythagorean section. And you also have double angle identities. Those are going to come up quite a bit, and it's good to have these things memorized. Sine of 2x equals 2 sine times cosine, and so on. There's about 5 of those. So 5, 8, 9. So that's 9 trig identities you really should have memorized by now. And let's see how to apply them. So first example, solve the following equation, blah, blah, blah. And you can see right away, this thing has different trig functions in it. Okay, we've got a cosine squared over here. We've got a sine over here. And there's no greatest common factor. There's no way to trinomial factor this thing. So now we're just going to go into trig identities. And which one should I use here? I have a feeling, because of this cosine squared, I have a feeling that the Pythagorean identity is the way to go. Let's just try it out. Worst case scenario, it doesn't work, right? It's no big deal. So I'm going to say 3 sine omega over here on the left equals negative 2 times cosine squared. Now, what is cosine squared? That's just 1 minus sine squared omega. Remember your Pythagorean identity substitution. And now look at this. I've got sines everywhere. This is much better. I might be able to factor this. So keep on working with it. And we get negative 2 times 1 is negative 2 plus 2 sine squared omega. And this should look familiar to previous equations that we've done before. I'm going to just rearrange this so I've got 0 on one side with all my terms on the other side because I think we're gearing up to some trinomial factoring here. I'm going to add 3 sine omega to each side. And now I have this equation, which hopefully factors nicely. You can use substitution if you want here. This is 2 sine omega on one parentheses and sine omega on the other. Now let's see, what do we need to multiply? I'm going to guess this is going to be plus 2 and minus 1. And if you want to use a big X, that is great. Substitution works very well. I'm just speeding through this. So double check the factoring. There's my 2 sine squared. There's plus 2 sine. There's minus 1 sine. So that's plus 3 overall. And then minus 2 at the end. So that all works great. And now my two solutions are, or getting towards that, 2 sine equals 1. So in other words, sine omega equals 1/2. That's one of my solutions I got from this guy right here. And the other solution that I'm going to get over here is sine omega equals negative 2. And that's a D&E right away. You can't have the sine of an angle being greater than 1 or less than negative 1. Okay, so that part's easy. And now we're just going to go ahead with this sine equals 1/2 portion. Well, if you remember your unit circle, sine is the y values, and the y values of 1/2, those are kind of low down here towards the x-axis. So what are these angles? Well, that's the shallow angles, pi over 6 and 5 pi over 6. So those are my solutions. Pi over 6 and 5 pi over 6. And see, the only challenge to this problem, assuming you know your beginner trig equation stuff, is seeing that identity, that Pythagorean identity substitution that we made right here. Okay, this was the big breakthrough moment. So let's move on. Let's do this one. Cosine squared minus sine squared minus cos. Well, what's the oddball? I see cosines. Those are nice. And then I see a big old sine squared in the middle like a fly in your soup. So let's try to use a Pythagorean substitution to make this simpler. Cosine squared omega minus, and instead of sine squared, I'm going to say 1 minus cosine squared. That's the identity substitution, the Pythagorean identity substitution. And now look, it's all cosines. So this becomes, if you simplify it, combine your like terms, it's going to be 2 cosine squared minus cosine omega minus 1 equals 0. Okay, that's quite nice. That's just going to give me 2 cosine omega, and it's going to be something there, I'm not sure yet. Cosine omega. So looking this over, I think that's going to be a minus 1 and a plus 1. Okay, double check the factoring, that looks good to me. And this gives us, on the left, it's going to give us cosine equals negative 1/2. And on the right, it's going to give us cosine equals 1. And those are both very nice values on the unit circle. Cosine equals negative 1/2. Those are these sort of steep angles right here. And cosine equals 1, that's over there. So I have 3 angles for this one. I get cosine equals, or I get angle equals 0. And going counterclockwise, looks like my next one is 2 pi over 3. And my next one is 4 pi over 3. There's nothing else really to check at this point. You could look for domain restrictions if you want, but there are no domain restrictions because our only functions are sine and cosine, and those functions have no domain restrictions. Any angle is fine with those. So there we go.